There's not a lot of clinical evidence because this is all pretty new still. There's been 2 preclinical studies that were done kind of before our studies where they found that if you actually inject orexin preclinically into the brain, you can promote seizures. So we know orexin can be excitatory, but these studies were showing that it can actually either make seizures worse or promote these seizures themselves as it's an excitatory protein. There's orexin receptors in the hippocampus, and so this is probably one of the key regions that are involved in the propagation of seizures and the worsening severity of seizures. So that was one piece of evidence, and that was a little bit early on. Simultaneously, we were also, as I mentioned before, looking to determine whether or not blocking orexin as it improves sleep, whether it would reduce seizures. And so one thing that we found a couple of really important pieces of evidence that link orexin to epilepsy. One is we did subdural recordings and depth electrode recordings in the lateral hypothalamus. And we found that the severe seizures that we were able to record on the cortex actually propagated all the way down to the lateral hypothalamus. And we know that if you have seizures in specific brain regions and severe seizures, it might actually cause a neuropathology, or it might cause some neuroplasticity and changes in the system. And they may be compensatory and beneficial, or they may end up being pathologic. So we did find that the severe seizures propagate down to the lateral hypothalamus. And so that would then maybe implicate orexin. We also looked at histology studies. We found there's a little bit of pathology. There was an increase in astrogliosis, which is common in epileptic regions in the brain. And there was also neurogenesis, or there was an increase in the number of orexin-expressing neurons. And so there was more orexin protein down in the lateral hypothalamus. Now, it's important to know that orexin only lives in the lateral hypothalamus, but it projects everywhere and it influences most of the central nervous system and, central nervous system and autonomic nervous system, both sympathetic and parasympathetic. So that was the second line of evidence, that there was an increase in actually the orexin signal in the number of neurons in the lateral hypothalamus. And then I think the last piece of evidence linking orexin to epilepsy is that if we blocked the orexin receptors acutely, so if we just blocked the orexin receptors with a dual orexin receptor antagonist, so we're preventing that signal from spreading through the brain, and then 30 minutes later, we actually evoke and induce seizures, we found that the drug blocking orexin receptors, the DORA, that the DORA actually protected 50% of subjects from actually having a seizure. And then in the ones that did have a seizure, their seizures weren't nearly as severe. And so both of those, or collectively, I think all 4 or 5 pieces of evidence are really strong indicators that orexin is linked with seizures and epilepsy. No, the nice thing about orexin, it's already, or a dual orexin receptor antagonist, is that it's already been FDA approved to treat insomnia. So we already have drugs that are clinically on the market. So it makes it a little bit more of a translationally relevant target. But also there's a lot of really exciting preclinical studies that are being done in other fields that I had mentioned earlier, from Alzheimer's, Parkinson's, multiple sclerosis, pain, addiction, cancer, neuroprotection. And those studies are actually looking at targeting just orexin receptor 1 or orexin receptor 2 to see if we can even get more very specific effects. And so I think moving forward, one therapeutic strategy would be to go straight to the dual orexin receptor antagonist, or the DORA. The nice thing about the DORA is that because it's FDA approved, I had mentioned that almorexin was the first one. There were some side effects. So now the newer one that's on the market and used is suvorexant, or Belsomra. So suvorexant is nice. You can use it at nighttime, but it does, in the context of using this drug that was initially used as a sleep aid, one side effect is that it's going to promote sleep. So I think it'll be really interesting to see whether or not we can make this a useful drug target. It could definitely be used for sleep and epilepsy. You take it before you sleep. And we have shown preclinically that it would reduce seizures during your rest period. I think the next question would be whether or not it could be a 24-hour drug, perhaps targeting just orexin receptor 1 or orexin receptor 2 may have promising future effects in just reducing the seizures without promoting sleep.